SolBridge Wi-Fi. If it's not necessary, please disconnect. It tends to be a little unreliable, and my computer's using the Wi-Fi, so if it doesn't work, then we get disconnected. So, all right, let's get started. So today we'll actually start with we'll look at the preview question that I posted. There were 4 parts to that. We'll look at the first 3 parts of that, and then some extra questions relating to that today. And then the last part of that is what we'll continue with this in our next class. Good morning. So 2 days of just kind of review some basic concepts with linear algebra. So this is the vocabulary we talked about last time. I'll have another slide where we review this. And we are starting a bit late, but I'll try to go quickly, see if we can have some time to review some vocabulary about, sorry, let me move the mouse off the screen there. You see. Yeah, we see the mouse twice, which is very confusing. All right, so preview of some vocabulary relating to costs, revenue, profits, just sort of basic business concepts, and get some formal definitions of that stuff so we can use that in our next class. So some administrative stuff. You guys are section 3, you're the green class on Google Classroom. So like you should be registered formally for section 3 of this class and in the green one on Google Classroom, and then also listening now. So please make sure that you're in the right section for everything, for attendance and grading. It's a lot harder for us, or it won't happen if you're in the wrong places. All right, last time, some vocabulary that we talked about. I didn't really highlight this, but I'll just mention it again since we already talked about it. Inverts, so just flip something upside down. Specifically in the math world, we're talking about a fraction, so flipping the top and bottom of a fraction, or inverse is the noun version of that word. And we also talked about lowest common multiple, so 3 and 4 and 6, lowest common multiple is 12. Like if we're adding fractions, we do something like this. So some vocabulary that's useful. Give everyone a chance to write it if they are. Okay, so invert or lowest common multiple. The other vocabulary that we reviewed last time, so axes or axis, singular axes, we have the y-axis and also the x-axis. Which of these is usually the independent variable? X. So it doesn't need to be, but pretty much everyone draws their graphs like that. So x is independent, y as dependent. Points, coordinates, we talked about that. I think that wasn't too tricky, but the origin, remember, is this special point here of 0, 0. So fancy name there. Equation of a line, something like this, and y equals 0.5 x minus 1. We'll look at some more examples of that today. Intercepts, we had this word intercept, and then also separately, it's hard to see if I write it low, isn't it? Right here. Intercept or intersection. What is the difference between an intersection and an intercept? Okay, you have part of it. You want to add the details?
Intersection is when two equations of a line crosses, and intercept is when a line crosses axis.
Okay, right. So an intersection is just where any two random lines meet. The intercepts, so x-intercept or y-intercept, is a special kind of intersection specifically with one of the axes. So intersection is the more general term, but if we're talking about this one or this one, where our line is crossing, the red line is crossing the x-axis or the y-axis, specifically that's an x-intercept or y-intercept. Slope, we talked about as sort of the steepness of the line. Does it go up or does it go down? Does it go up very quickly or just a little bit? And we'll talk about the ways of calculating that today. So those are the terms we'll need. All right, so these were the questions. Again, like I said, most people were okay with these. I saw a handful of people who had some mistakes on the third one. And then a lot of people were a bit confused about the fourth part and how to do that. So we will get to that in our next class, the fourth one. The rest we'll do today. So this is the topic. This is linear algebra. This will take us pretty much all the way to our midterm. So kind of core skills this week. Next week, just review of finding intersections of lines, how to calculate that stuff. We'll do a bit with break-even points there. And then we'll talk about matrices, so systems of equations with matrices, and then do linear programming. It's an optimization thing with inequalities, which connects to linear algebra. And then probably the last topic before the midterm will be different uses of matrices, matrix addition, matrix multiplication. But it's all kind of within the scope of linear algebra. Okay, so to uniquely identify a point, and I'll go through this quickly because everyone was okay with this, we have coordinates for any of these for any point here. So for example, point A, if we want to know where is point A or how can we refer to point A, then, well, we want a pair of numbers which will look like this. We'll have an x coordinate and then a y coordinate. So something x and then something y. And to get the x value, we just look at our points, and then the x-axis, we just draw a line that connects the two, a perfectly straight, perfectly vertical line, and we just see where it crosses. -2, so that's the x coordinate there, and y coordinate, same idea. Perfectly horizontal, flat line, and where does that cross? -3, so -3, and those are the coordinates. So xy pair, 1, 2. Or the other way that we can think about these, if we just kind of want to count off, let's say we're looking at B, then where is B? So just count from our origin how many steps right or left first for the x value. This is to the left, so that's negative. So 1, 2, 3, 4, 5, 6. So 6 steps left, so -6. And then how many up or down? Up is positive, and it's 1 step, so just 1. And that's how we have our coordinates. So just up and right are positive, left, down, negative. Okay. Yeah. So let's say we're going in the other direction. Instead of having a point and figuring out the coordinates, let's say we have coordinates and we want to figure out where the point is. Well, we just do the same thing, but in reverse. So let's say we have point C here, and we want to put that on our graph. Well, we just find 3 on our x-axis and just draw a line straight through that. And then we find 4 on our y-axis, draw a line straight through that, and there's our point right there at that intersection here. So this is 3, 4, or again, just counting. So if we have a 3, it's positive. We're going to the right 1, 2, 3 steps, and then going up. So 1, 2, 3, 4 steps, and there's our point. All right, I think, again, most people were okay with this, but let's just make sure. Please tell me 3 different points that are on line f of x here. 1, 1, 0, 3.
Minus 1, 5.
Okay.
Minus 3. Oh no, 3 minus 3.
So negative 1, 5 there. 3, negative 3. Yeah, so you can see
4, negative 5.
lots of these. And also we can kind of see if this is kind of exactly 1 and this is exactly 0, then it would make sense that halfway between would be exactly 0.5, so 0.52. So lots of points we can find. I won't write them all in. All right, so going very quickly just because, okay, I can't, the mouse for that computer is over, whatever. Okay, so going a bit quickly, if you have questions about this stuff, please ask as I'm going through this, otherwise I'm just gonna keep going. So one of the questions I asked you was to find the distance between these 2 points. And we want the exact distance, so just like trying to count on this grid or something and just kind of guessing, that's not very precise, so we want to do a slightly better job than that. What is the basic strategy to find the distance between any 2 points? Okay, what formula? And then what's the logic behind the formula? What's the reasoning? What does the formula represent?
The Pythagoras theorem.
Okay, well, what is Pythagorean theorem? What does that tell us? You can't just know the name. We have to like actually know how to use it. So what am I going to draw here on this graph first?
A triangle.
Okay, so drawing a triangle on our graph. So we have our target distance, target length here between A and B, that straight line. So let's call that C, and then let's call the other side here that's close to A, lowercase a, and the other one B. So what's the relationship that we should know or remember?
A squared plus B squared equals C squared.
So we notice that we have a right angle here, exactly 90 degrees. And if that's true, A squared plus B squared equals C squared. And then, okay, so maybe we've just swapped this for a different kind of problem. What is the length of A and what is the length of B?
A is 4. Length of A is, the length of B is also 4.
4 squared equals C squared. Okay, so how do we get those lengths? Well, we're just counting the points here, like how many steps on our grid, 1, 2, 3, 4. Or we could think of the coordinates of these points. So we have -2, -3, and the other one we have -6, 1. So what's the horizontal distance between those two? Well, we just do -6, like this, -6, and then we subtract the other one, so -2, and that's -4, but just the, as I mentioned, the absolute value. So we don't care if it's positive or negative, we're just thinking about a distance. So we just treat this as just 4. So it doesn't matter what the sign is in this case. And do the same thing for the vertical distance. So the width here, the base is 4, the height is 4, and then we just do our squared here. So 16 plus 16, c squared 32 is c squared. So c is equal to what?
Square root of 30.
Square root of 32.
Okay, so the 4 root 2, we'll get to that in just a moment. Why would I not write the plus minus in front here?
Because this is the absolute value.
Right, it's just length. Like we don't care, like you don't say I walked -5 kilometers to get home. You just say I walked 5 kilometers. We don't care about the direction here. It's not a vector. So we have that, and then if we remember our square root rules or exponent rules, we can split this up. So 16 times 2, and then further, root 16 times root 2. If you have two things multiplied together with an exponent or a root like this, you can split them up. Root 16 is just 4, so 4 times square root of 2. So that's the cleanest way of writing this. Square root of 2, we might know it's 1.414 ... but this looks much nicer instead of an infinite decimal. So distance between any 2 points, right angle triangle, make a right angle triangle with 90 degrees, Pythagorean theorem, and it's pretty easy to figure out what that length is. So that's the strategy there. Okay, everyone's all right. So that's the same thing, just typed out. You can take a screenshot of that or go look in the recording later. All right, so next part, we'll talk about equations of lines. So our line f of x here, how can we uniquely identify a line? There are two basic ways to give the properties of a line. What are those things? If I want to draw a line on a grid, what are the minimum information that I need? So
Points on the line.
okay, so any 2 points. If I have 2 points, then I can draw a straight line between those 2 points. So if I have point A and B, I could do this, and that's a unique line. There's only one way to draw a line, a straight line between A and B. So if I have 2 points, that is one way to identify a line. There's one other way. If you think of the equation of a line, what are the 2 pieces of information that are actually in that?
Coefficient.
The slope and y-intercept.
Okay, slope and an intercept is a point, so a slope and a point. Those are the other 2 options, so the other option. So any 2 points will uniquely identify a line, or slope and any points will also uniquely identify a line. Slope and point is what we use for the standard equation of a line, this y equals mx plus b, where m is slope and b is the y-intercept. Remember, intercept is just a point. So let's say if we want to find the equation of this line, f of x, then we'll start with the intercept. So concept of intercept, again, is just where our line is crossing the y-axis. So that's right here. What are the coordinates of this point? It's 0, 3. By definition, if it's an y-intercept, if it's a point on the y-axis, then the x value will always be 0. So if it's not 0, then it's not a y-intercept. So that will always be 0. So to talk about this point, we don't really need two numbers. We just need one number, the y value. So in this case, it's 3. So that's the y-intercept. So 3. So building our equation here, y equals mx plus, now we know what b is. We know that b is 3. So that's our point. That's our location for the line. Now we just need to figure out the slope. And that's the next slide. Okay, so slope is, again, the steepness or incline of a line. So talking about angles is one way to describe the direction that a line goes. Slope is a different way, a completely different way of doing it. Both work, but when we talk about this kind of graphing, we use slopes because it's very useful. So our basic formula for a slope, which, okay, just so we can all see this, I'll write it up at the top. So m equals delta y over delta x. What does the delta, the little triangle, represent? Change. So change in the y values compared to, or divided by the change in the x values. So if we just take any two random points, let's say we have this point here, 1, 1, and second point over here, 3, -3. We choose, doesn't matter as long as they're actually on the line. And we just calculate what is between those 2 points, what is the change in y and what is the change in x. So we could just count it. What's the change in y? Well, we do 1, 2, 3, 4 steps, and then 1, 2 with x. Or if we don't have the graph handy, we can just use algebra and use the values that we have here. So change in y is y2 minus y1, and right, divided by x2 minus x1. How do we choose which point is the point number 2 and which one is point number 1?
The point number 2 is the y twice the y point. Basically, you have a b point, for example. The first coordinate and the second coordinate.
I'm not asking which one is the x and which one is the y, but we have 2 pairs, right? This is a point and then this is a different point. Okay, so trick question, we don't care. It doesn't matter what order we do it in, as long as we just don't like mix up the coordinates for the points. So let's just say we'll do this one over here as 2 and this one over here as 1. So y2 is -3 minus our y1, so 1, and divided by our x2, so +3 minus +1. So that just turns into -4 over 2, which we can simplify to -2. The -4 over 2, that's what we would have gotten if we did our sort of steps from point 1 to point 2, -4 down 1, 2, 3, 4, and the +2 on the bottom of the fraction writes 2 steps. The other more general way of thinking of slopes, which again, just some people get confused about how to actually understand a slope intuitively. This number is just saying if x goes up by 1, so if we take 1 step right with x, how much does y change by? So this is saying if we go right along x 1 step, y should go down by 2. And we see that for all of these points on the line here. So if we start here, x goes up by 1. So right by 1, and then y should go down by 2. That takes us to this next point on the graph, and then takes us to the next point, and then all the points that we talked about before. So our full equation of this line, y equals -2 x plus 3. So -2 is the slope, and +3 is our y-intercept. All right, that is the equation. Again, most people were okay with this part. So let's try this. We'll have a different line here. So 0.5x plus 0.5, and we want to draw that line. So let's say that maybe slopes are confusing for us and we're not quite sure how to work with that. What is the most basic way to actually draw an equation on a graph? Something that will work for any kind of equation, even some sort of curved, confusing thing like this.
Choose random x's and then find the y's.
The y value. Okay. So we do something like this, and we just choose some values for x. Let's say it's -2, -1, 0. Any kind of points that, or any numbers that we think will make our math easy. And then we calculate what the y value would be. So this approach, this method, we call making a table of values. So the other methods of using slope and such, those are kind of shortcut methods that work nicely for straight lines or other special cases. But this table of values will work with any equation whatsoever. If you're not sure what it looks like, make a table of values and you can draw a bunch of points and get a sense of it. If you, the way a computer draws a line like this, they're just making like an infinitely big table of values and then just putting all those points on the grid. Okay, so if let's start here with 0. Looking at this equation here, if x is equal to 0, what is our y equal to?
0.5.
Okay, so 0.5, we just substitute 0 in for the x value. When x is 1, what do we get?
We get
1. When x is 2,
we get 1.5.
okay, so 1.5. And then we see the pattern here. It's a linear pattern. It's pretty easy to observe. So then the next, this would be 0. So -0.5. So this is the approach here. Again, once we do maybe 3 of these, we can see the pattern and we don't have to manually calculate all the other ones. So table of values, and then each of these is a point on, these are coordinates, so 0, 0.5, and we just draw those points on our graph, 0, 0.5, so that's a point here. And we draw the other ones. Let's do this one, 2, and 1.5, and then we can take another point here. Okay, so I did say that 2 points are enough to uniquely identify any line, but if we just want to, make sure that we haven't made a mistake with our math or something, 3 points is usually a good, safe amount. So find 2 of them, draw the line between those 2, and then calculate a third point and make sure the third point is on the line. So if we drew the line, but then we figure out our third point and the third point is like down here or something, oh, that's not on the line, we've made a mistake. So at least 3 is just a good way to confirm that you've done it correctly. As with most math, maybe it's a lot of work to find the answer, but checking your answer is usually easier and doesn't take too much time. So this is how we can confirm our work here. by choosing an extra point. So table of values will always work. All right, let's do another one here. Let's say we found the distance between A and B, but let's say instead we want to find the equation of the line that's going through A and B here. Oh, what? I'm not even touching that computer. So 1 second. The only way to make that message appear is to press the Windows key and the G key at the same time. And like you saw me, I was not touching that computer. Okay. Right. So let's try that again. So if we want to find the equation of this line. So once again, our equation, the basic form is this y equals mx plus b. So we need to find m and we need to find b. Which of those two do we normally find first? Why are you saying b? Easy? Okay. So it's on the graph. Yes, we can see we have -5 here. Let's do the harder version of this. Let's pretend that we don't have the graph here and we just have the points. So 1 second, I'll just say, so we have point A, which is -2, -3, and we have point B, which is -6, 1. That's the only information we have, and we don't want to draw a graph. So how can we use algebra to figure this out? Slope first, okay. And our slope formula, the thing that we talked about before, delta y over delta x. So we'll choose which one should be 0.2, which one should be 0.1. Okay, so choose one for me. B is 0.2, okay. So that would give us y2 minus y1. So our y2 is 1 minus -3. And then as our other one, we have our x2, -6 minus -2. Okay, so this will turn into +4 over -4, which is -1. Okay, so at this point we have our equation y equals, sorry, not m, -1x, so just -x plus b. And now we just need to figure out what our b value is. How can we figure out b? Okay, so one of the points and do what with it? Okay, so we'll take one of these points. Remember, these are coordinates, so it's an x, y pair, and we have, there's the x, there's the y. We'll just put them in, substitute them into this equation, and then calculate what our b should be. So -3 equals minus -2 plus b. -3 equals 2 plus b, b equals, and here we get our -5, which again, we could see on the graph pretty easily, but we've now confirmed that that's the exact value using our algebra. You know, most of the time, your graphs are going to look pretty nice and clean like this, but we don't always know that it is exactly -5. It could be -5.1 or something. So being able to confirm this with the algebra is very useful. So whole equation, y equals -x minus 5. And we found the whole thing. Let's say we're not 100% confident. How can we check our answer here? Okay, give me a little more. Which x, which y would we put in? A or B, which one's the better choice?
The one with the lower numbers.
The one that makes the math easier. Could be, I'm gonna say there's, even without that, if they're both easy, one of these is a better choice.
Because the one with the positive number is easier.
Okay, let's forget the easier. Which one's more reliable?
Minus 2 and 1 and 3.
Why? Okay, you have an idea?
Because now you calculated the equation with a point, and then you're always going to find the same outcome, but if you put another point and then that's on the line, and then you can control if the equation is good.
Okay, so it's more reliable if we do it this. So we used A to find the B intercept, so maybe we made a mistake here. So if we use point A to confirm this final thing, we're just gonna get the same mistake will still be in, and it will look okay, but it could be wrong. So using point B would be more reliable. Ideally, if we had like some other point C that we haven't touched yet, then use that one to confirm everything. But if your work is sort of relying on some of the points, so the less, if you can find some other point that you haven't used yet to confirm your final results, that's the best way. So B would be the better choice here. I'll skip that step, it's not very hard, but that would be a more reliable choice in this case. All right, I think we're doing okay for time. Some special cases for graphing here. So let's say we have these 4 different things that we want to draw. So we'll start with this one. Y equals -5. Is that a line? Like it doesn't look like a y equals mx plus b. It's just y and then some constant value. Is that a line that we can graph?
Yes.
Yes.
Okay, how can we graph that one?
First,
A
put the X.
Okay,
equals on the line.
-5 on which axis?
No,
Y.
5 on the y-axis.
And do a little bit
-5 on
down.
the y-axis. Okay, so perfectly flat line like this.
So it's parallel to the x-axis.
Right, parallel to x-axis. So the way to understand this is it's basically y equals 0x minus 5. And then 0, a slope of 0 means a perfectly flat horizontal line like this. The next one, x equals 2. What can we do here? Okay, so same idea. So we find 2 on our x-axis, but then we're drawing a perfectly vertical line parallel to our y-axis. I won't show all of this, but if we were to try to turn this into a regular equation like our y equals mx plus b, we would see that we have a division by 0 problem. So something on the top divided by 0, and that means that we can't give a slope. We can't say what the slope is because division by 0 is undefined. So in this case, slope is undefined. So this is the one special case. If we have a perfectly vertical line that doesn't really have a slope, we just have to remember, like we can't just like choose 2 points and calculate the slope. We just have to remember if it's x equals something, that's a perfectly vertical line. 2 more here. Y equals 0. What does that look like? We already have it. Tell me what it is.
This is the y-axis.
Y equals 0. Which axis is this?
X-axis.
Okay, x-axis. So that's this one. This might seem a little backward, but remember y equals 0 means it's the points, all the points where the y coordinate is 0, and x can be absolutely anything. So x can be anything. And that is exactly what the x-axis is. The x-axis is the collection of points where y is 0, and then it's all the different possible values of x. And then same idea here, x is equal to 0 is actually the y-axis, like this.
Y can be anything.
Yes. So mathematically, these cases are actually simpler, but sometimes people would get confused because they're expecting the m, the b, everything, but these are simpler, so I just don't want to get confused by these. So special cases with perfectly vertical or perfectly horizontal lines. Okay, all right, wow, we're going very quickly. I think we're okay for time. So 2 things of vocabulary. We'll talk about these briefly, and then we'll talk about the cost, revenue, profit bit, because we'll need both of these for our next class, and then that'll be it. So, what color? Let's do blue here. So if we have lines that are intersecting, we have 4 different possibilities. So first case is just kind of regular, boring case, nothing special happening. They intersect and 1 point, and they're just intersecting lines, no special symbol for that. A special case of that is this, where the 2 lines intersect and meet at exactly a 90-degree angle. So that's what this symbol is here. So these are called perpendicular lines. Perpendicular means 90-degree angle. The next case, 2 special cases that could happen in a 2-dimensional system. We could have parallel lines. So the 2 lines are running at they have the same slope, and they will always be the same distance apart. They will never cross, they will never get closer, never get further apart. So they'll always stay same distance apart. How many points of intersection are there in this case?
There are no intersections.
0. 0 points of intersection here. And then our final case, other special case, is coincident lines. And it's a bit hard to draw a picture of this because they just end up looking like the same thing. But it's 2 lines that are fully overlapping. Maybe the equations of the lines look different with some different numbers, but then when we put them on a graph, they end up looking like the exact same line. So fully overlapping. So we have this symbol for this one. And in this case, how many points of intersection do we have? Infinite. So every point that's on one of the lines is also on the other line. They are perfectly overlapping, or we could even think of them as being the same line. So it's an infinite number of points of intersection. So 1, 0, or infinite. These are the 3 basic possibilities for types of intersections. So the vocabulary here: perpendicular, parallel, coincident. All right, everyone has that. And then we'll go through some practice questions with this stuff in our next class. So the other thing to talk about today are just to get clear definitions and some basic sort of formulas and ways of talking about cost, revenue, and profit. All right, sorry. I forgot to mention to everyone online, the webcam on my laptop sort of works half of the time and not the other half of the time. I ordered a new one. It's just, it's coming. So I don't know. We normally have a different classroom, but if we are in this situation again, this probably won't. I'll have a camera that I can use. Okay, so let's try to make kind of some formal definitions of each of these things here. So let's say we are business owners and we have some car factory. How do we define cost, revenue, and profit for this sort of scenario?
Cost is basically how much you spend, for example, on raw materials. It's cost for your company producing cars. Revenue is basically
Only raw materials?
no, just for an example, what cost can be for the car producing company.
Okay.
Revenue is basically how much you sell your car and how much money you get, and the profit is revenue minus cost, means the money that is like left for you. This is the difference between cost and revenue.
Okay, good. All right, so I'll repeat that so everyone online can hear. So production costs, that's basically what we're talking about. It's not like cost to the consumer that we would call price. So cost is our cost of making this thing or providing whatever service. So revenue is basically the price prices paid by consumers. So it's the money that we get in from the consumers from whatever thing they're buying. So let's say our production costs for each car is $6,000 and materials and labor and everything, and we sell our cars for $10,000. Well, then our profits is $4,000, just the difference between the two. If we want to be really technical, this is gross profit. Net profit would also consider like the advertising cost and like the lawyers and then the CEO salary. But those things are not directly relating to the production. So those are a separate thing. So here, just gross profit. Okay, so we'll get a little more definition about each of these things here in some terms. So if you haven't seen these already in your microeconomics class, it'll come up soon, but we have just a standard way of talking about costs. We have fixed costs and variable costs. So fixed costs is FC, variable costs as VC. So fixed costs are fixed. They do not depend on the number of things that we sell. So if I'm going to build a factory to make cars, like I don't build a new factory for each car, I build one and then I keep reusing it. So that's a one-time cost. On a day-to-day basis, if I make one car, if the factory's on and we're making cars, then let's say we have to turn on the lights on the ceiling so people can see what they're doing. If I make 10 cars in one day, or if I make 100 cars in one day, it doesn't matter, the lights are on the whole time. That's a fixed cost which does not depend on the number of things that we produce. So variable costs are the opposite. Those do directly depend on how many units we are producing. It's the materials for that thing, it's the labor for that thing, it's the shipping for that thing per item. So variable costs, fixed costs are just some number, you just add everything up. Variable costs are the cost per item here. And then you multiply, so you know what those costs are, and then you multiply that by quantity sold. So this might seem a little odd. You might think, well, quantity produced would make more sense, but we want to be able to compare revenue and cost directly. So if we use quantity produced for calculating costs, but then quantity sold for calculating revenue, then they're different values and they're not directly comparable. So instead, we always talk about it as quantity sold. So that way we can make a larger equation for profit using the same Q value. So Q is quantities sold, not produced. And there's, if you run an efficient business, you only make as many as you're going to sell or pretty close to that amount. So variable costs are just your Q, quantity times cost per item. So total costs, TC, is the variable costs plus the fixed costs. Just put the two things together. So that is the standard way of talking about costs for a business. We'll do a little bit of that next week, and then a whole bunch of this when we get to our calculus stuff at the end of the semester. On the other side, a bit simpler, revenue. So TR for total revenue, we'll be using that a lot as well. So total revenue is just price, P, times quantity sold. So again, quantity sold, same as the costs one, that allows a direct comparison between the two values. So P times Q gives our total revenue. So again, price is price paid by the consumer. It's the label, the sticker price in the store. All right, and the last part of this is profits. So profit is just revenue minus costs. So that's our TR minus our TC. And so if we put all that together, that's total revenue, price times quantity. And then our total cost is the variable costs plus the fixed costs. So we have our revenue minus our costs, and then that gives us our profit. Question?
Back to the previous slide.
So let's just think for a moment about these values. Is price a constant or a variable?
A variable.
Okay, let's think for a particular, like maybe we don't always know it for like, if we looked at like 100 different products, it would be different for all of them. But if we're selling one product, we have one kind of car, I don't know, like we're Tesla and we only make one kind of car and just sell that to everyone. Is our price constant or variable? It's constant. Like each person walking into the car dealership doesn't, like I don't make up a new price for every person. It's here's the price and everyone pays that same price. So price is a constant. Costs per item, which can vary, but for a simple situation, in like a kind of a short term, this would be constant. So we will look at cases where it's not constant, but that requires calculus, which we'll do later. But for now, when we do our linear stuff, we'll pretend that this is constant. And fixed costs, fixed, so constant, those are not changing. So it looks like we have one variable here and then one other variable here with our profit. So this is kind of like a y equals some sort of slope, some coefficient on the Q value, mx plus b. So we can make a single linear equation that represents this because these values will be fixed. And again, if the values are not fixed, then we can make a different equation, but we'll get to that later. So costs we can represent with a straight line. Revenue we can represent with a straight line, and then if we just subtract one from the other one, we make another straight line that represents profit. And we'll see in our next class how just actual representations of this. But those are the terms, and these are just sort of the basic standard ways of talking about costs and revenue and what sort of labels and variable names are used. So you will see these quite a lot, so please get familiar with these. Wow. Okay, I don't know how, but we started 10 minutes late, and I finished basically everything 5 minutes earlier than I did with the other classes. So it's good that we didn't miss anything. Does anyone, I was going quickly, does anyone have questions about anything we've talked about today? All right, so some wrapping up stuff here. The graphing stuff, like here are coordinates, or this is what a slope is and how we calculate it. Here's how we find an equation of a line from 2 points or whatever. If that stuff is new for you or you completely forgot that stuff, please go back and review that in our textbook. So chapter 3.1 is all about just points and coordinates. Chapter 3.2 is about slopes. All of this is posted on our classroom page as well. And chapter 3.3 is about lines and equations of lines. This is some fairly early high school review. I'm going to assume that all of you have learned this before and you are still like, kind of familiar with it, like that this was not too tricky for you. If this stuff is really hard for you, please go back and look at that material. I've posted a whole bunch of review questions. These are some of them. So our textbook is very good with the review questions in that it splits them up by section and by like particular skill. So here's like one very specific skill, and here's like 20 questions to practice this one. Here's the next very specific skill and a whole bunch of questions. So you can just easily find, this is the thing that's easy for me, I'll skip those ones. This is where I'm having trouble, I'll do a bunch of these. So it's very well organized like that, and lots of questions for you to go through. The examples that are in the textbook, like I gave examples today, and then there are different examples in the book. They're well done. There's very good detailed explanations of it. So I'll recommend that. The workshop that we'll have Thursday this week will also be just a whole bunch of practice questions on exactly this stuff. So you can come to that as well if this is tricky for you. If you do all that and it's still hard, then you should probably schedule like a meeting or a tutoring thing with me for someday. Okay, so if the basic graphing stuff is totally new for you, please do some review on that and make sure you're familiar with that. We're going to be using this a lot for most of the semester. Do I have anything else? Parallel, next time, Zoom stuff I already talked about. Okay, I think we're finished. So I will see you all on Thursday, and then maybe again Thursday afternoon for the workshop. The sign-in, attendance sign-in, that's there. If you forgot to sign that paper, or if it didn't get to you, please sign that before you leave. And I believe we'll be back in our regular classroom on Thursday. Goodbye, everyone.